Welcome to Textile Update, the podcast where we can share our passion for textiles, fibers, and yarns. This is Gwendolyn Hustvedt.
This is the second of two episodes where I introduced this idea of fabrication. In this episode, I'm going to narrow in on what sort of properties are created in fabric by fabrication. So we can continue our idea that what we know about what a fabric is made of or how it was made can tell us something about how it will perform. Last time we were talking about fabrication, we ended by talking about the variety of different types of looms across history and how they produced fabric. This podcast episode, I really want to narrow in on what happens during weaving, what the results in the fabric, what we can see in the fabric. So we've talked about how a loom works. Let's talk about the fabric now. First of all, warp yarns and filling yarns are different, and we can use those differences to actually identify which direction was the warp and which direction was the fill, even if the fabric has been removed from the loom and is being sold to us, even if a piece has been cut out. Now, if you're using a swatch kit, then you might notice that the swatches in the swatch kit are cut in a rectangular manner, and that's because the lengthwise yarns are the longer yarns in the swatch, and the filling yarns are the shorter yarns in the swatch. So, in fact, they've kind of tried to imitate what a big piece of fabric would look like in that little tiny swatch. So we don't need to think about, which was the warp and which was the fill, because we always know, the fabrics that are the fibers, the yarns that are going up and down in the swatch and are longest are the warp yarns, and the yarns that are going from side to side and are shorter are the filling yarns. But what if we have a big square, a 12 by 12 inch square, and we're not sure? First of all, one of the things to know is that the yarns in the warp direction, there are typically more of them in an inch. It's because they were preset, right? So we preset them and then we inserted the filling yarns. And so we can never fail to have the correct number of warp yarns that were in the loom, right? That were set in the inch of the warp. We can only fail to get the right number of filling yarns into that inch. And so if there's going to be one that has fewer, it's more likely going to be the filling direction. Warp yarns are also more tightly twisted, and we talked about twist when we learned about yarn. Twisting makes the yarns smaller and makes them stronger. So the yarns in the warp direction are more highly twisted because they need to be stronger. This ends up making them smaller, so yarns in the filling direction are going to be larger around the yarns in the warp direction. The yarns in the warp direction are also straighter. So if you have two directions, you're not sure, you pull yarns from each side, compare them, lay them side to side, let them rest a moment, and you'll see that the yarns in the warp direction are stronger, they're more difficult to break, and they're also straighter. You could also, without even removing yarns, kind of bounce the fabric in each direction because the yarns in the weft direction have more elongation. Any elongation that the yarns in the the warp direction would have had has already been stretched out of it, right? Because it was under tremendous tension during weaving. The yarns in the filling direction are going to be more dimensionally stable because the yarns in the warp direction that were under tremendous tension might want to relax a little bit. So there could be something that we call relaxation shrinkage, which is where the warp yarns actually shrink a little bit right after weaving. And so this could be why, if you were young, it doesn't happen as much nowadays because more products are sold pre-shrunk. But when I was a kid, I knew that the pair of jeans that we bought from the store were going to shrink by an inch or so, that the length of the pants were going to shrink. The warp yarns that were going up and down in the pants were going to get shorter because of relaxation shrinkage. So my mom would say, oh no, the first time we wash them, they'll get shorter. So that's why we have to buy them a bit longer. How annoying for consumers to have to plan that into their shopping. The yarns in the filling direction are always going to drape a little bit better, right? And so we will plan to, this works out for us, lucky us. When we manufacture garments, we have the warp direction going up and down in almost all garment parts. And the filling yarns going from side to side in almost all garment parts. And this works out. If you make a bicep, it's the yarns wrapped around your arm that need to stretch a little bit. But it does mean that as you stretch or as you bend your arm, places like your knees and your elbows are pulling against the stronger, more dimensionally stable yarns. So over time, those areas will end up getting abraded because the yarns just had less give. Lastly, if we were looking at a fabric and had to guess, right, we're saying, oh, well, these yarns are smaller, so they probably are the warp yarns. If we see any fancy yarns or novelty yarns, those are more likely to be in the filling direction. We just can't, we wouldn't put a boucle yarn through the heddles in a harness, right? We wouldn't wrap them around a warp beam. It would just be such a mess. Whereas we could put them on a shuttle and use them that way. So if we look at a piece of fabric, we can see that the fabric in the warp direction is stronger and straighter, has a stiffer drape, and stretches less. And all of this is due to the higher twist in the yarns in the warp direction because we needed strong yarns that were going to withstand the tremendous tension of weaving. And as I mentioned, those yarns do shrink more because when we remove the tension and put them into the washing machine the first time, it's like getting into a jacuzzi, right? Add a little soap, right? Like bubble bath, right? And those warp yarns just go ha 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 ha, right? And they relax and they actually end up shrinking back down to their original length. They were stretched thin and now they can relax. So we call that relaxation shrinkage. If you look at a piece of woven fabric, there are some other details that you can see besides that the lengthwise grain, the lengthwise yarns are smaller and stronger and straighter, and the crosswise yarns are more likely to be novelties. There's probably going to be slightly fewer of them, etc. Heard me mention the word grain. I didn't mean to, but I slipped. We call the grain the direction of the fabric that follows either the lengthwise or crosswise yarns. There's like lines that we can follow there. There's a direction in the fabric called the bias, which is any direction that isn't the lengthwise or crosswise direction. True bias is actually exactly 45 degrees between the lengthwise and the crosswise direction if the lengthwise and crosswise grains are at 90 degrees to each other. This is why we can get so upset when we have fabric where the grain is off, where the crosswise grain isn't at 90 degrees to the lengthwise grain. Maybe it's at 80 degrees, right? We then end up with extra stretch we weren't planning on. And when we pull in the crosswise direction, we don't get the results we expected because we're not actually pulling on crosswise grains. We're kind of pulling on, 80% of the crosswise grains. We can also have an occasion where the crosswise grains don't tilt in one direction or other, which is called a skew. A skew. It is a skew, so we call it skew. We could have a bow. And that would be where the filling yarns actually kind of sag a little bit in the middle, right? And as a result, we have yarns that are not at 90 degrees, but they go up in one direction and up in the other direction. So we end up with very unpredictable results. These fabrics that are off grain are considered lower quality. And low quality fabrics are used to make products, for example, that are sold at outlets. And this can explain part of the reason why fabric at an outlet doesn't feel the same. When fabric is skewed, it actually, when you stretch or make a bicep or something, it can bind and feel weirdly tight in a way that you didn't expect. Now, besides the lengthwise grain and the crosswise grain and the bias direction, which is basically a 45-degree angle between the two, another thing we could notice about a piece of fabric is that the edges of the fabric, which are called the selvage, even though it's spelled Selvage, so we would expect that it was actually pronounced selvage, but we don't have to say that more than the one time I just said it. Thankfully, we can say selvage like it's spelled Veg, right? Or Edge, like edge. And that's what I want you to think of. It's the edge. It's the self edge of the fabric. And the selvage is woven very tightly in order to keep the filling yarns from slipping. Actually, in many cases, the selvage is woven using what's called the lino weave, which we'll learn about later, a special weave where the warp yarns actually twist around the filling yarns in order to keep them especially stable, so the filling yarns don't end up sliding out of the fabric. could be problematic, right? We don't want them to change their position at all. So the selvage is something that we can see when we look at a whole piece of fabric. And that will also tell us that we're looking at the warp direction because the selvage follows the lengthwise grain. Another thing we could see if we looked at the fabric and we used our pick class is we could count how many yarns are in an inch. I actually have a video on my YouTube channel about how to count yarns in an inch. So just now I'm going to talk in general about the math instead of the how to do it. The number of yarns in an inch is called the thread count, right? And that is always expressed as the number in the warp by the number in the fill. Now we use an X to say by, so we might have like 80 yarns in the warp and 80 yarns in the fill. And so we would say 80x 80. I'm not going to fight with people out there in the industry, but they'll say thread count and they'll use a number that we actually call the fabric count, which is the warp and the fill added together. So if we had a fabric that was 80 by 80, 80 warp yarns and 80 filling yarns, then we would say that that had a fabric count of 160 yarns in an inch. Low count fabric is sheer and is used for things like cheesecloth, where we really want all that air and liquid to go through the fabric. And high count fabric is very often opaque and a bit stiffer and might be used for end uses where we care about those properties. I will talk in a little bit about why that whole thread count thing with sheets is such a scam. But we have to get to learning about the interlacings for us to get there. So just for now, thread count is the number of warp yarns by the number of filling, and fabric count are the two added together. So a little bit of math here in our fabrication discussion. And just to think about the properties we've talked about before, I mentioned that low count fabrics have more air permeability, but they also have more trouble with yarn slippage. On the plus side, they drape more easily, but they are less ravel resistant and have lower dimensional stability compared with high count fabrics. High count fabrics, have more yarns per inch, like that's how it's defined. But that means those yarns have higher twist. That's how we fit them all in there, right? We twisted them until they were very thin and fine. But like it's a literal physical impossibility at a certain point, like how many yarns you can fit in an inch, right? You physically can't insert thousands of yarns per inch. So at a certain point, you just know people are lying when they give you such high fabric counts. The high count fabrics are stronger because there are more yarns, right? Although, as I mentioned, we have to talk a little bit about the interlacing pattern to think about what effect it might have on properties like ravel resistance. But in general, higher count fabrics are stronger. One other thing that we might talk about when we think about the properties of the fabric that we can see when we look at it is the balance. How many warp yarns are there compared with the filling yarns? We will use this to actually identify the proper name to call the fabric. In some cases, everything else about the two fabrics will be the same. Same kind of yarns, same twist in the yarns, same size of yarns, right? Very similar appearance, but the difference between the two will be that one has a lot more warp yarns than the other, and that means that it's unbalanced. So if we have a 1-to-1 ratio of warp yarns and filling yarns, roughly, we don't have to get too persnickety, but roughly, then we would call it a balanced fabric. So if we had 80 warp yarns and 76 filling yarns, which would be written 80x 76, we would call that a balanced fabric. But if we had 160 warp yarns and 80 filling yarns, we would call that an unbalanced fabric, and it'd be a 2-to-1. So written 2:1, that's how we write a ratio. And then 3-to-1 would be 3:1, and that might have, for example, 210 to 78. Right, so roughly 3 times as many. Again, can't get persnickety, but when the balance shifts, right, when it's 2.78 to 1, then we would call it 3. You can figure this out by looking at a swatch and pulling some yarns from each edge and looking to see which fringed edge it actually looks thicker, right? So that could be one way to tell balanced and unbalanced fabrics that are otherwise very similar apart. And this gets important because like broadcloth versus percale, right? The difference in definition literally just comes down to balance. Another thing we can see when we look at the fabric, besides how many yarns there are or the proportion of the yarns in each direction, we will begin to see the interlacing pattern. Here's another spot where I really recommend that you just do an internet search for interlacing patterns, looking for things like a plain weave, a twill weave, and a satin weave. I could also really recommend that you get some graph paper and use a pencil and actually draw these weaving patterns out for yourself. Students who are studying at trade schools who are going to go into the weaving business are studying this right now. They're learning how to map out the interlacing pattern using darkening in grid paper in order to determine what the pattern should be. And actually, there's a whole database of weaving patterns that have been collected over the centuries. Very often, recently, they've been collected by people interested in computer programming because of the relationship between weaving and computers. So, for example, the gentleman who started the computer science department at University of Arizona, they still maintain his weaving instruction database where he saved all of these weaving patterns because of this relationship. So if we see that every warp yarn goes under every other filling yarn, so number of warp yarns over and number of warp yarns under the filling yarn, if that is a 1-to-1 ratio, so it goes over 1, under 1, over 1, under 1, then we would call that a plain weave. If it goes over 2 under 1, we would call that a twill weave, right? So we can follow the filling yarn and we can see that it goes over 1 warp yarn and under another warp yarn. And we're following the filling yarn because the filling yarn is the one that's been picked, right? So we're inserting it, right? So if we were literally lifting the warp yarns by hand, we would lift 2 and then pull 1 down. You did this in kindergarten when you wove a little May basket, right? Or a pot holder, right? So over, under, right? But if you went over 2 and under 1, right? Or under 2 and over 1, you would have a 2-to-1 interlacing pattern. And if you were making a satin weave, the definition of the satin weave is 4-to-1. So we would go over 4 and then under 1, or under 1 and over 1 and under 4, right? But either way, we would have this 4-to-1 interlacing pattern. Of course, satin weaves can go up to 6 or 7. Now, it's important to know about this interlacing pattern because, as we'll learn later when we talk about the difference between plain, twill, and satin weaves, the fewer interlacings you have in a fabric, the less snag resistant it is, and the more yarns you can fit in an inch. And so a fabric that brags about having tons of yarns only got there by skimping on interlacings. So it's actually reducing its strength. So yeah, you have more yarns, but the yarns are now smaller because they had to make them so small to fit them in the inch, and they're not even being interlaced properly. And so at a certain point, after about 300 yarns, 300 fabric count, right? So 150 yarns in each direction roughly, you stop gaining the benefit at the same rate. So when we get to 400, we might say, well, that's still a higher quality than 300, but after that, it's first of all, it's not really possible, and it's ridiculous. You're just not interlacing the yarns as often to get to that high of a number. And in fact, people lie all the time about this and get sued by the Federal Trade Commission for lying because you're not supposed to lie to consumers. And yet, it's only recently that some companies have really set up really good websites where they explain why 1,200 count thread sheets aren't a thing, first of all, and secondly, even if it was a thing, it wouldn't be as good as what you think, right? Because you stopped gaining after a certain point. Let's see, another thing that we might talk about or we might be able to see that might help us understand what fabric we're looking at or its properties. This is less about what we see under a pick glass and more what we might see on a scale. So if we put the fabric on a scale, we might say, oh, this fabric is very light. Now I'm going to give you the imperial weights because it's just what I happen to know off the top of my head. But we need to remember we live in an international world now, and so you want to be able to quickly convert between grams per meter squared and ounces per square yard. So even though I'll use ounces per square yard all the time, it's just because I'm older and you are living in an international trade world where grams per meter square is much more common and dependable. So lightweight would be something less than 4 ounces per square yard, medium weight would be between 4 and 7 ounces per square yard, and heavyweight would be more than 7 ounces per square yard. We might also hear people refer to top weight and bottom weight. Top weight would be lightweight, and would be used for blouses, right? Or, lighter things that you would wear on top. And heavyweight would be a bottom weight, right? Because they're used for things like pants. Coating weight would be heavier than suiting weight. You might see those as well. Both coating weight and suiting weight are still in the heavyweight area. Lastly, you could take a piece of fabric and hold it up to the light, right? And if the fabric is sheer, if you can see light through it or you can see your fingers, then we would call that fabric sheer. Whereas if we couldn't, we would call it opaque. And so I could describe a fabric as being a lightweight, sheer, balanced weave with a one-to-one interlacing. And you would be able to tell me what kind of fabric that is. You would say, oh, that sounds like a batiste. Is it made from cotton? Right. So those terms help us think about all of the things we can see when we look at a fabric. And except for all of the yarn count part doesn't apply to knits, but the weight and the translucence, certainly we could use those terms if we thought about knits. Most of this applies to wovens. Wow, I feel like I've just downloaded millennia of history here into one short little podcast series with 2 episodes here where I've just talked about fabrication. There's so much more to learn about it, but I just wanted to give you the merest introduction to some ideas that we'll be using as we talk about weaving in the next podcast episodes.